We're going to continue our study of exponential functions. Now we have our general formula, y equals ab to the x power. If a is bigger than 1 and b is bigger than 1, then it represents exponential growth. If a is bigger than 0. If a is bigger than 0 and b is in between 0 and 1, the function will represent decay. So let's take a look at growth and decay. Growth is if b is bigger than 1. Decay is if b is between 0 and 1. In either case, the y-intercepts are 0a, domain is real numbers, and the asymptote is y equals 0, that's the x-axis, and the range is bigger than 0. Now let's talk about a couple of examples of each. Okay. Pretend you had y equals 2 times 3 to the x. Well, we should probably note that you see this 3. That 3 is bigger than 1, so that 3 tells you that it's going to be growth. Okay? And that's going to tell you that the y-intercept is 0, this value, 0, 2. Alright, so I talked about a growth one. I'm going to talk about another growth one. Y equals 0.4 times 1.5 to the x. I'll put that in parentheses to make it look a little easier. Okay, I'll put it in parentheses. I'll take away that dot. That might help you visualize it better. Alright, you see this 1.5? That represents growth because it's bigger than 1. And you see this 0.4 out here? That's your y-intercept. Has nothing to do with growth or decay. It would just be your y-intercept. Now let's talk about two decays. If you have y equals 1 times, let's do 0.8 to the x. 0.8 is smaller than 1, so it would be decay. And 1 would be your y-intercept. Let's talk about another decay. Y equals 5. That number, remember, that number doesn't matter. Times 0.9. No, let's make it a fraction. Let's do 8 over 11. Sure, that's smaller than 1 to the x value. See how this is smaller than 1? That represents decay. Okay? And this would be your y-intercept, 0, 5. Down here, how can you tell how much something grows or decays? Well, it's all about b. Alright, so underline this and write all about b. Alright, it's all about b. So let's say y equals 2 times 1.8 to the x power. Alright, this is b, right? B is 1.8. Well, what you need to do is you need to figure out how far from 1 is it. Okay? Well, this one is 0.8 away from 1, and it's above 1, so we would say this one has 80% growth. Let's try a couple more examples. Let's say y equals 1 times 2 to the x. Well, b is 2. And, well, how far away from 1 is that? So if you do like 2 minus 1, okay? Actually, let's do that. Let's do minus 1. That might help you. How far away from 1 is it? That equals 1, right? Well, that as a percent is 100%, and it's bigger than 1, so this one's a growth. Okay? Let's try y equals 0.25 to the x power. B is 0.25, and if you take away 1, you get negative 0.75. That means that this one is a decay of 75%. Let's do another decay one. 3 times 0.3 to the x. Well, b is 0.3. Take away 1 is negative 0.7. Therefore, this is a decay of 70%. Let's apply that to problem 2, identifying growth and decay. You're going to focus on B. This one is B, okay? Notice that it is, we'll write B equals 0.95. That represents decay. Why does it represent decay? Because it's smaller than 1. Alright? And the y-intercept it asks for as well is 0, 12. Now let's have a little extra note here. This is a 5% decay. If you have questions on that, ask me tomorrow. Part B. We focus on this. B equals 2, and 2 is greater than 1, so this would represent growth. The y-intercept is 0, 0.25. Okay, now let's go a little further and say since it was greater than 1, we would say this one has 100% growth. You put $1,000 into a college savings account for 4 years that pays 5% annual interest. Okay? So what we're going to do is we're going to label like initial values and things like this. Okay? Well, I'm going to do y equals the amount of money you will have. Y equals for the amount of money you will have. You start at 1,000, that's like your y-intercept, times. Well, if it pays 5% interest annually, that's giving it to you. Remember 5% is 0.05, okay? So we're going to add that to a 1. So this becomes 1.05 to the x power. Alright? So the y-intercept is 0, 1,000. And this is a growth problem. Got it, number 2. Identify exponential growth or decay and the y-intercept. This one's a positive 4, so this one represents growth. The 3 on the outside is your y-intercept. Part B. This is smaller than 1, so it's decay. And your y-intercept is 0, 11. Part C. You put $2,000 in, so we make our equation starting at $2,000. The account pays 6%, so 0.06. Let's put that in as 1.06 because you have to add it to 1. We'll talk about that in a little bit. To the x power, okay? This is going to be growth. And your y-intercept is your beginning amount, $2,000. Now this next chart is really something that we've been talking about, alright? See this 1 plus r? I need you to understand that b is the same thing as 1 plus r. The b that we've been working with is the same thing as 1 plus r. I just want to make sure that you understand this is just another way of writing, okay, what we've been talking about. So we've been talking about y equals a b to the x. That is the same thing as amount of t, that's just a fancy way of writing y, equals a times the 1 plus r to the x. Well, I guess they use the letter t. Okay, these are the same things. Don't get confused. B just becomes something a little fancier, which we've been doing more or less in our head. You'll invest $1,000. That's A because it's your beginning amount. Okay? The account pays 5% annual interest. That's going to help us make up B. Since it's paying you, it's going to be plus 0.05 for 5%. You always add or subtract it to 1. Alright? Time, let's see, it says how much money will there be after 6 years? Time is 6. So we do y equals $1,000 times 1.05 to the 6th power. Plug that into your calculator exactly as you see it. If you don't have a fancy calculator, I'm going to show you how to do it kind of like, here, I'll show you on a regular one. I'll show you in here. Okay, you do 1,000 times 1.05 to the 6th power, and that is how much money you will have in the bank after that amount of time. So 1,340.10 cents. Be careful with your rounding. Don't miss a half point because you don't know how to round. All right, let's try this again. You invest $500, that's A. It pays 3.5%, now that's B. Since it's paying you its addition, that as a decimal is 0.035. And this one says time 5 years. So we say your amount will be, or Y equals, or if you want to be fancy, A of T equals $500 with your initial amount times 1.03, which talks about how much it's growing, how much your money is growing for 5 years. Okay, if you have like a normal calculator, if you don't have one of these at home, you can do 1.035 to the 5th power, like that, and then you can multiply it by the 500 at the end, and that will give you the same answer that I would get if I typed it in at once. $593.84. So, kind of neat to see your money grow. After 5 years, your money's grown almost $100. Let's do problem 4 now. This one we're going to have to use guess and check. If you want to, I can teach you how to do this table function, but I'll teach you how to do this tomorrow when we're all together. Suppose you invest $1,000, that's A, and the account pays 5%, so 1 plus 0.05, and you want it to equal $1,500, so they're asking you, how long are you going to leave it in there? Well, let's make our equation. We do Y equals our initial amount times 1.05 to the T power. But they told us we want Y to be, eventually, we want Y to be $1,500. So they're asking us, what is the T value that will make this true? Well, if we're going to round to the nearest year, okay, we're going to be specific with our years. We're going to have to use some guess and check, okay? So I'm going to say 1,000 times 1.05 to the, let's take a guess. Let's say 2 years. Well, that's not nearly enough. I need that number to be 1,500, okay? So I'm going to write down that I guessed 2 years, and that was definitely too small. Do the same thing, but I'm going to guess 3 years now. 3 years is growing, but it's not growing as fast as I need it to yet. Let's try 4 years. Okay, it's growing, but it's also not enough. I need that number to be 1,500. So why don't I go up, and why don't I guess like 11? Well, 11 is too much. So I'm going to write 11 down, but that's going to be too big, okay? These ones are small. This one was too big. So let's guess 10. Well, that one's really close. 10 is still just a little bit too big. All right, so let's guess 9. 9 is pretty close. I'm going to write that down. And now I'm going to try 8. 8 is not enough. So since we're talking about specific years, you need to be able to say the most specific year. It has to actually reach it. So while 9 was too big, 8 was too small. So we're going to say after 9 years, we will have $1,500. Yeah, we'll have more than $1,500, but that's the first time that it's greater than $1,500.